Lesson 2.1. We're going to deal with relations and functions in this lesson. First thing we're going to do is we're going to look at relations and graphing them. Domain and range. First of all, let's define those terms in your notes. Okay, the domain is the input values of a function, which are the x values or the x coordinates. Input is x. The range are the output values of a function, or the y values. So domain is input or x. Range is the output values or the y values. Alright, so this first thing we're going to look at is pretty much a scatter plot here. If we look at the graph, we're given 5 coordinates on that graph, and we're asked to state the domain and range shown in the graph. First of all, we're going to list the coordinates. So, and I'm going to go from left to right here, kind of work myself from leftmost point to rightmost point. So, leftmost point there, coordinates are -4, and then it's on the x-axis, so it's 0. And then if I go to the next point, the next point's at -3, 1. And then if I go to the next point, which is down on the bottom of the y-axis, right here, it's at 0, -2. And then the next point, again working myself from left to right, it's up in the first quadrant, they're at 1, 2. And then the last coordinate, furthest point to the right, is at 3, 3. So there is listing the coordinates. Now, coordinate notation, all that means when we have coordinate notation here is in a relation, okay, we're going to put ordered pairs or the coordinates, so ordered pairs in set braces. So it's a relation is a set of ordered pairs. And the set braces, remember, are these. Okay, so all we're going to do for coordinate notation here is take those list of coordinates we did and put set braces around them. I'm not going to rewrite all the coordinates, but that would be a relation, the set of ordered pairs, okay, in coordinate notation. So if they asked us to list the domain is the set of all input or x values, and you need to use set braces. So what we're going to do, and we usually go from small over to big, so in order from smallest to biggest, with our x values. Now, we went left to right with our points, so our x values are kind of in order, are pretty much in order small to biggest there. So it'd be -4. Okay, now we're not listing them as ordered pairs because we're just doing the domain, the set, or what's in the domain, what set is in the domain. So -4, -3, 0 is the next x value. So we have -4, -3, 0. And then 1. So we had 0, and then we have 3. And again, we're putting them in set braces. So when you are in a relation, you're asked to put the domain of a relation. It's all the x values or the input values listed from smallest to biggest. Then we're going to do the range. Range, again, is the output values or the y values. So now I'm going to do the y values from small to big, just like I did with the x values. So the smallest y value, and that's the second coordinate in an ordered pair, that I have is -2. And you can kind of look from bottom to top on the graph. So the lowest point has a y value of -2. Then we have the one that's on the x-axis, or 0. And then we have a 1, a 2, and a 3. So it's just listing the numbers from smallest to biggest. If you ever have repeat values, then you do not put them in the set twice in the domain or the range. Okay, the last thing we're going to talk about here is the mapping. Okay, our mapping. And we're going to come down here. When you're mapping, it's how the domain is mapped to the range. So what we're going to do, so here's the mapping. Domain. I'm going to list all my domains, and I'm going to call it D. So -4, -3, 0, 1, and 3. I'm going to list all my range values over here. Range is the y values, -2, 0, 1, 2, and 3. And then you just take the domain value. So if you go to the ordered pair, -4, comma 0 was our first ordered pair, our first coordinate we wrote down. So -4 is mapped to 0. So you draw an arrow from -4 to 0. -3 gets mapped to 1. So we draw that arrow. 0 gets mapped to -2, so you can have arrows crossing here. 1 gets mapped to 2. And 3 gets mapped to 3. This is called a it's a function. It's called a one-to-one function. Okay, there is not an x value, or actually there's not a range value that two different x values go to, or two different domain values. And you'll see this on the next slide here a little bit better when we talk about functions, one-to-one and not one-to-one. If you take a look at this, and this is not in your guided note packet, but this is just something to keep in mind when we're talking about functions, not a function, and things like that. So this is 3 different mappings here. If you look at that's 3 ordered pairs in this first one, -3, 1, 0, 2, 2, 4. Domain and range, so they mapped it very similar to what we just did on that example. -3 goes to 1, 0 goes to 2, 2 goes to 4. That is a one-to-one function. Okay? Each x value, there is not 2 different x values going to the same y value. Okay? Each x value is mapped to one y value. Okay? This one, if you look at what's the difference between the first and the second one here, if you look at the middle one, -1, 5, 1, 3, and 4, 5, notice it's a function, because we don't have 2 arrows coming off a domain value. Okay, and that's what we'll get to in the last one. Okay, it's a function, but as you notice, -1 gets mapped to 5 and 4 gets mapped to 5. So we say that's a function, but it's not one-to-one because both -1 and 4 are going to 5. So it's not a one-to-one function like the first one was, where we didn't have 2 arrows coming to the same y value or range value. Okay, this one over here is not a function. Here's the reason. This domain value, -3. -3 gets mapped to 0 and it gets mapped to 6. If you think about graphing these two, and if you look right here, we got -3 in twice. If I plot those 2 points, -3, 0 and -3, 6, I'd go -3, 0, which would be on the x-axis. Let's just think of it here. I'd go -3, 0, should be right there, and then -3, 6, which would be up here. And I'm not going to plot the other points, but we're going to get into the vertical line test next. Notice if I drew a vertical line right there, it would go through those 2 points. So that relation would not be a function because it wouldn't pass the vertical line test. Remember, if any vertical line goes through more than 1 point, it's not a function. That happens when you have repeated x values. Functions that are not one-to-one are when you have repeated y values. They're still functions, okay, because there's not the same x value going to 2 different y values or the same domain value. All right, and we'll get into the vertical line test here on the next slide. Okay, here's the definition of the vertical line test. Okay, so if you want to write this down, if no vertical line intersects a graph in more than one point, the graph represents a function. So this one right here on the left would be a function. Okay, every vertical line I draw, if I drew all kind, they have one drawn in there, but if I drew any vertical line, it would only go through the graph at one point. Over here, this is not a function. If a vertical line intersects a graph in 2 or more points, the graph does not represent a function. Notice, if I draw any line here, it would intersect in more than one point. It's not a function. If you have a point above, you could draw many vertical lines there that would show it's not a function for that one. So let's give you some examples here. Let's say I had a line like this, and we're just going to answer, does it represent a function? I'm going to put function, question mark. Okay, well, this first one, if I drew all kinds of vertical lines, that one would be a function, because every vertical line I draw only goes through that graph in one point. If I had something like this, vertical lines, any vertical line you draw only goes through in one point. So that is a function. Well, let's look at this one. Let's look at a parabola. Goes like this, goes like this. If I drew vertical lines, anywhere there, every vertical line, because that parabola keeps going out as you go to the left and to the right, that one would be a function. So all 3 of these that I've done so far passed the vertical line test and is a function. How about if you had a graph, similar to this? Let's say, kind of looks like a sideways parabola. Would that be a function? Well, if I draw a vertical line right here, passes in 2 points. Vertical line right here, passes in 2 points. And you only need one vertical line, pass in more than 1 point. That's not a function. Okay, likewise, if you had any other one that passed in more than one point. Let's look at, and we'll get into more of these later in chapter 2, but let's look at a graph like this. Open circle, over to closed circle. And then we're going to jump up, open circle, over to closed circle. Open circle, over to closed circle. Open circle, over to closed circle. This is what we call, it kind of looks like steps. And this would be a function. Okay, now, some of you may be saying, well, why does that pass? Because if this is a closed circle and this one's open, that's okay. Same, notice when above the closed circle are open circles, okay, this is actually a function because they're not, but if they were both filled in circles directly below or above each other, then they would not be a function. But this one would be. This is actually called a step function. We'll look at later in this chapter what produces a step function graph. Okay, and these would continue to go on like that as you moved out in that direction. If we had, let's just do a scatter plot. So if I have a scatter plot, looks something like this, okay, or a relation. And I said, would this be a function? What you got to look for in a scatter plot is, look at all your points, and if you have any points that are directly above and below each other, like this right here, that would not pass the vertical line test because that vertical line would go through more than 1 point. So this would not be a function. So this just gives you some examples with scatter plots and different types of graphs, what you're looking for. Okay, now we're going to get into the equations. We're going to look at first equations of functions in relations. Okay, if you just have a set of ordered pairs, then your graph is a scatter plot. Okay, you're just plotting the points. Could be a function, could not be, depending on if it passed the vertical line test or not. Now we're going to look at a linear equation. If you notice, this is in y equals mx plus b form, which is called slope y-intercept form. You've dealt with that a lot over the last couple of years. Remember, in that form, m is your slope. Okay, so the slope is 3. M is what's in front of x, so that would be this right here. Now, we probably, when we graph it, want that as a fraction, so we can make 3 a fraction by putting it over 1. This is b right here. This is b, which is the y-intercept. In this case, it's -1. So when you're plotting these, there's kind of 2 steps. If you have it in slope-intercept form, instead of making tables, which are very time-consuming, plot the y-intercept as your first step. So our y-intercept is -1. We're going to plot -1. Okay, and then use the slope to find your next point. Okay, and remember, m is the slope. It is rise over run. If your slope ever ends up being negative, I would always put that with the top just to be consistent. You can actually put it with either, but I would say just always put it with the top to make it consistent, which always makes your run positive. But so I want to rise 3 and I want to run 1 from this point. So I want to go up 3. You know, I'm starting here at -1 on the y-intercept. That's my y-intercept. I want to rise 1, 2, 3, and I want to run 1. So I'd be right here. Okay, so notice from that point I went up 3, to the right 1, and then draw your line. So we'll draw our line, and actually you could repeat this. I could rise another 3, run another 1. I could go down 3, left 1. You can kind of see where they're going to line up. I could go down 3, left 1 again, rise 3, run 1. Now you only need 2 points to draw the line. I'm putting them on there because of the line function in my smartboard. Then I can go from here, and actually you need arrows on both ends. But there's what our line looks like then, okay, with arrows on both ends. So there would be the graph of that line. All right, now we're going to get into, and you've done slope-intercept method of graphing before, but now we're going to get into finding the domain and the range. So I'm going to label them domain and range. And I'm going to do them in set braces. Domain is the set of all x such that what's true? What x values are graphed? Now, if you think about this, this line goes down and out, kind of towards -infinity. As I go down and to the left, it goes up and to the right. So think about the x values. It's going infinitely to the left as it goes down. It's going infinitely to the right as it goes up. And basically, every x value is graphed. So we say the set of all x, that it's all real numbers. Now, there's a symbol that we use for real numbers, okay, which is kind of an R with a double barred left side of the R. Okay, you can use that symbol if you want, or you can write all, you can write all reals. The range is y's, or the output values. So what y values are graphed? Think about this line. It's going infinitely down and infinitely up. Range is y, so that's up and down. So, and it's connected, and it's all real numbers. When we say all reals, that includes every decimal, fraction, whatever you're talking about. Okay, so in a line, the domain is all reals, the range is all reals for this particular line. Determine whether the relation is a function. This does pass the vertical line test, so yes, it is a function. Okay, so we'll put yes, passes the vertical line test.